developers on making their life a little bit easier for us. So could you build this with Kafka? Absolutely. And would I use Kafka if I would build a demo like this if I wouldn't have Kinesis? I probably would. What Kinesis does for you is that you don't need to worry about managing a Kafka stream. What it would mean if you run your own Kafka, you would need to run multiple servers, at least 2, to make sure that it's highly available, and then you would need to scale them out. Overall, unless you do a fairly good job in utilization calculation, it's probably cheaper to use Kinesis than running Kafka on EC2, because EC2 you're not charged on throughput, but it would be on on the per instance kind of hour charge, and you would need to figure out the rest and how to scale it. While something like Kinesis is per transactions per second kind of charge, where you say 1,000 TPS, that's what I pay, full stop, right? 2,000 TPS, this is what I pay. If I need more, I just adjust it, and I get that part. So achieves probably the same thing, but with Kafka you would need to manage it yourself. If you don't want to do that, then something like Kinesis is interesting.
I have a question about GPU servers, because when you provide those GPU servers, if I just launch like 2 or 3 instances, do I have to manage the parallel data by myself, or I can just treat it as I have like 16 GPU, or I have to manage the data by myself?
So the question is if we have multiple GPU instances, if we could have a common data layer in between. So from our perspective, there's no restriction in doing that. You would just need to have a file system that would allow you to do that. One way of doing that would be using something like an HDFS or Gluster MS that distributes the file system across the GPUs. Another way would be using a clustering software that potentially has integration to it. Depends on your use case. When it just comes to storage, so if it's simulation and it's heavy on the GPU but not heavy on the data, it's probably easiest to use a distributed file system and then use multiple of those. We get different sizes of GPU instances too. So if you say I just need a bigger one, you can also resize those instances on the fly. So you just say shut down, give me a bigger one with more GPUs, bring it back up, do my simulation and shut it down again. Those are also elements that you could do. So I would probably in that scenario I would look at, why do I need multiple GPUs? Is it to get more performance? Could I achieve the same thing by scaling it, the individual instance up? If not, well then, is it only storage that I have distributed? Then potentially just Gluster MS, HDFS will do. Otherwise, maybe something like Spark can even be interesting. If you say, I want to have a distributed in-memory cluster, but tap onto the GPU for certain computation, you could also achieve that through it. Obviously, you need to write the CUDA language in Spark, but yes, you could. Okay. Good questions. Sorry. Any other questions for today?
Question about GPUs for that quality. So, how do performance compared to the CPU or GPU? Because I heard that the simulation by software is not really public.
Yeah, so in terms of the question, what's the difference between the CPU and GPU performance? It's a tricky one. So the way you can see it is GPUs are really good at doing certain operations. And you'll find that if you use a GPU, like an EC2 GPU, you need to use CUDA language, which is an NVIDIA chipset-specific language, and that allows you to do certain operations. If you can do those operations, you'll find a huge performance increase here, because a GPU, like the smallest one that we offer, I think has 1,500 something cores, right? Comparing that to most virtual servers that potentially only have like 2 cores, maybe 16 cores. Here you tap onto thousands of cores. The larger ones, they have over 8,000 different cores, I think more than that even. So you suddenly have all those cores that you can use, but only for operations that are supported by that language, right? So if those operations are supported, and for like neural networks, so that's a good pattern here, some certain simulations, then you get a much better performance boost on the GPU. But you can't kind of fully compare it, because a CPU has so many operations that it can do. GPU is limited to only a few. those are very useful for certain use cases, like rendering, which is what the GPU was designed for, but another one is machine learning algorithms to do simulations, for example. And here the benefit is you get thousands of more cores instead of the normal CPU to parallelize that operation. Yeah. Good question. Great.
请问还有问题吗？OK， 那因为其实刚刚一开始的时候，我们也介绍一下，那个 Olivier 他目前的话是那个 AWS 的 Specialist， Machine Learning 的 Specialist。那他目前非常忙碌，因为尤其是在10月初的时候，他即将去美国拉斯维加斯那边会有一个 re:Invent 的活动。那他们百忙之中，现在还愿意到我们社群分享一个这样的议程，我是非常感动，非常感谢他。所以我们最后还可以先跟他鼓励一下，谢谢那个 Olivier。
And please feel free to if you have any ideas or feedback, something you want to hear about in terms of AWS and R or anything specific, post it to the meetup group, send it to me, send it to Noah. I'm happily, coming back, talk about something you really want to hear about. This was just an overview, but feel free to just drop me your questions, ideas you want to have. Happily addressing that. Thanks. Thanks.